Hi, it's Jan Beta, and today I'm going to do some long overdue maintenance on my 1970s turntable, which is a Technics SL-1710. So here it is. This is my own Technics SL-1710, my beloved turntable that's usually hooked up to my hi-fi in the living room, and I love this thing to bits. It's a very down-to-earth, semi-automatic turntable from the late 70s. These were made by Technics in 1976 to 1978. It's a Technics direct drive, so the motor is super reliable, works really well. This thing is super heavy, weighs around 9 kilograms, I think. Semi-automatic, that means it has an auto stop, but it doesn't auto play, which I kind of like. And this thing is totally working. It sounds amazing with my Orthophone 2M Red that I put in there recently. Absolutely love this. Unfortunately, it has developed some signs of age. One of them being that the tone arm lift is just dropping. So we don't have any dampener oil left in the tone arm lift. I think that's one of the issues I want to address today. And the other issue that you have to address sooner or later with these vintage turntables are the electronics, mostly regarding the electrolytic capacitors in these. Usually the power supply section is just a transformer and the AC voltage is transformed down, rectified, filtered by some electrolytic capacitors and then used for the control circuitry, for the motor and everything else that is in this turntable. And these earlier ones are not quartz controlled or anything like that. They use a classic chip, which is the AN630 made by Technics, that is in many of these classic Technics turntables, and that provides the motor controls and is also the driver for the motor, I think. And the issue you run into is that the electrolytic capacitors dry out over time and wear out. They have a limited lifespan. Some of them might be leaky, even physically just leaking the electrolyte out of them, which of course results in the mains voltage not being filtered properly, and that endangers the other electronic components in here, especially the chip, which is super difficult to get these days. They don't make them anymore for, I don't know, 30 years or something like that. So that's a spare part that you don't want to have to source, because if you get lucky and find one, you are either going to have to tear down another turntable that uses the same chip, or you find like a new old stock thing for hilarious prices. But I didn't even see new old stock anymore. So basically, if this chip breaks, you're basically doomed and have to find another way of controlling the speed of the platter on this turntable. So I'm going to replace the electrolytic capacitors in here and take a look at the dampening oil in the Q-arm. You want this to go down slowly to not risk damaging your needles or your records. Yeah, you definitely want to do both of these operations. And then I'm also going to give this a bit of general service, like lubrication and things like that, because I didn't do that in a long time. I did lubricate the mechanism when I got it. That was about 10 years ago. So it's about time I took another look at this. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do other things like CNC machining, 3D printing, sheet metal fabrication, injection molding. Basically, they produce everything you need as a tinkerer with electronics or other projects. The pricing is super reasonable, quality is awesome, and delivery is fast. So I highly recommend checking out the link in the video description in case you're interested. Back to our record player. We're going to have to dismantle this pretty much completely to get to all the parts we want to work on. That's going to be a bit fiddly, but the first steps are rather easy. We're just going to remove the head shell completely and put it somewhere safe, because I don't want to risk damaging my cartridge here. We're going to have to remove the platter, and then we are going to open this up and have a look. So this already has the protective thing on there. This just screws. And I'm just going to put this somewhere very safe. You can actually lock this in place. That's a good idea. The platter is just this rubber mat that we have to remove, and then the platter itself which actually comes with this warning notice. Turntable platter of this set is part of the motor assembly, therefore do not remove the turntable platter unnecessarily. Do not connect the AC power plug when the turntable platter is removed, this may cause power supply problems. Never let dust or iron filings come in contact with the rotor magnet. If lubrication becomes necessary after approximately 2000 hours of playing, remove the turntable platter and apply 2 or 3 drops of the enclosed special oil to the top of the bearing. I don't have that enclosed special oil, but we're going to use something else that works. So this just lifts out. You can use these holes to lift it out straight up, because you don't want to bend anything. And there's the huge magnet in here, and these are the motor windings. So this indeed is the magnet that is the motor, basically, together with the windings. So with the platter and the cartridge removed, we can now turn this upside down carefully. I'm just using the lid here to prop it up. If you don't have a lid on yours, you want to prop it up, you don't want any weight to go on the tone arm, because that can be dislocated quite easily. In order to open the top side of it up, we're going to have to remove these feet here. So these 4 feet have to come off, and then we can lift the whole top portion of the turntable, which we're going to have to do. You can also open this backside here where there are some additional mechanics. We're going to do that later, I think. And then we turn it around again, and we should be able to lift the whole top portion of it. We also want to remove this part here. Could remove the lid, but not going to bother with that, I think. Should all be nicely accessible like this. So this should now lift out. There we go, and there's our circuit board. So this is literally all that's to it. The top portion has the circuit board screwed in from the bottom. This is the whole control circuit, motor driver circuit. That's all the circuitry that's in here. And our chip that we were talking about, the AN630, is under this heatsink here. Yeah, we're going to disconnect everything. I think this just plugs in. This here comes out. And we also want to remove this here. There's a cable tie here that we are going to have to remove. Just going to cut this. We're going to put another cable tie in there later. I think we can lift this out. Yeah, and this is all connected. This is one piece now. We're going to look at this portion later, I think. The bottom, and we're going to take out the circuit board and replace the electrolytic capacitors first, I think. I think that's the order of operations for me now. So the circuit board is also secured with a couple of screws. Here and here and here and here, I think. And this is the connection for the output, really. This is the output board with our ground and our audio outs. Which is pretty nice. That just plugs into this connector here, coming directly from the cartridge, the tone arm. Yeah, we have to remove these. And this is the ground screw, which has a little star washer on it. This center screw here is a ground screw that has a little star-shaped washer on it. So we want to put that back there where the copper contacts are showing. So we are going to have to remove these screws too. These are for the speed adjustment potentiometers. And we have to pull the knobs. Yep. This one also has to come out. That's somewhat connected to the heatsink. Yeah, that's the one. Now we can take the circuit board out. Yeah, and it seems the whole metal chassis is also connected to the heatsink, so it acts as a heatsink as well for the chip here. And I think what I want to do is to take this heatsink out as well and clean that and put some new heatsink plaster on there. This is our switch for the mains voltage. You can switch this to different AC mains voltages, but we don't have to fiddle with that. I'm just going to give this a bit of a cleaning and then replace all these little electrolytic capacitors, the cans here basically. Yeah, and there's not much to it, as you can see. There's a couple of film capacitors in here already. These are not really much to worry about usually, but the electrolytic ones have to come out and be replaced. I'm also going to spray some contact cleaner into the speed adjustment portion of this board. There are potentiometers here that you can basically reach from the other side, I think. There's usually a little cavity in there that you can spray some contact cleaner in. And then we're going to replace the capacitors. And I don't think I want to remove any other wires from this. This should give us enough room to work on this properly. I'm going to fire up my desoldering station. And as you can see, there are quite a few different types of capacitors on here. This large one, that is the main one you want to replace, definitely. This is the mains filter cap, so this is responsible for filtering the AC to become DC voltage, to then supply the rest of the circuit, the motor and the chip. And yeah, if this one develops ripple, that can damage the AN630 chip. And I have some 470 microfarad 63 volts Vishay axial capacitors here that I'm going to use to replace the big one. And then for the very small values, there's a lot of 1 microfarad and 0.22 microfarad and 0.33 microfarad. I'm going to use these MKT, which are polyester film capacitors. These are really good, and I think they didn't use them because these were not available at the time. These are very much more reliable than the ones that are on here and should be fine electrically. These are WIMA brand. I'm going to link the exact ones I use here in the video description in case you want to do the same. Same goes for the ones I used for the other larger microfarad values for the electrolytic capacitors that I'm going to use, but the small electrolytic capacitors that are originally in here are going to be replaced with these polyester film capacitors. Modern plastic capacitors. So I'm just going to heat up the desoldering station and go one by one, so I don't get the capacitance values mixed up or anything like that. I'm also going to link the service manual for this in the video description, which thankfully is readily available still. You find a list of capacitors in there as well. Some of these are bipolar. These are BP capacitors. These polyester film capacitors are all bipolar, so we don't have to worry too much about that. I think the bipolar ones are these here, which are C9 to C11. I think these are the bipolar ones. The other ones seem to be polarized. If you want to use electrolytic capacitors for these, which are also still available, you want to use bipolar caps in these positions. I think that's pretty much covers it all. You want to use good brand ones, of course, for a valuable piece of kit like this. I'm usually using Panasonic FC for the regular radial capacitors, and the Vishay ones are one of the only brands that still makes good quality axial caps. You could probably fit a radial cap in here by bending the leads outwards and just send it up from the board. Probably it would fit fine. This is just a single-sided circuit board, so it should be relatively easy to work on. And while we're here, we can also look at resoldering some of the solder joints, which all look fine, really. I'm just going to start and dig in. This large axial capacitor had the legs on the solder side bent inwards quite a bit, so I'm going to try to replicate that. Probably for vibration protection. Just going to do the same, I think, because that seems like a good idea. Because obviously this whole thing is going to slightly vibrate while in use. So that was the big one. That should be in nicely. I'm just cleaning the residue with some isopropanol so we don't have any flux residue on here. Yeah, and now it's the same for all the other capacitors, I think, with the difference that these are radial and not axial. I just desoldered the first 1 microfarad one, that's here, C20, and I'm going to replace it with my 1 microfarad polyester. And the spacing of the holes here is actually so wide that you can easily fit these. This fits perfectly in here without even bending the legs or anything. Oh, and the modern capacitors don't have a polarity, so you can put them in either way, even for these positions where there were polarized capacitors in there. And that's all our electrolytic capacitors replaced. As I said, the bigger values, bigger microfarads, I replaced with electrolytic capacitors and the other ones with modern plastic capacitors that should do the same job but better and last for a longer time. You want to use like 105 degrees Celsius rated modern caps for the electrolytics because they last longer. The Vishays unfortunately are only available as 85 degrees Celsius rated ones, but still they're going to be longer lasting than the original ones, at least at this point. I want to get this heatsink off, and I think we have to remove 2 screws here and this 1 screw on the transistor here, and then replace the thermal compound that's on there with fresh stuff. This has a nut on the back, the transistor here, and this just screws into the heatsink, these 2 screws. So let's remove these. And of course the whole thing is going to get another good scrubbing with isopropanol. Just grab this nut from the back here. And this should now come out. This has a little washer on it to isolate it from the heatsink. Don't want to lose that. And we want to put it back. And there's a Mylar washer under here. Let's remove the other screws. And then we should be able to get the whole heatsink out there. Oh, this also has some washers underneath. Ah, there it goes. Old school. This is our old school chip. And I'm just going to clean both the heatsink and the chip of the remnants of the old thermal compound and put new stuff on there and then screw it back in. And these have some washers, so everything is isolated from the heatsink, actually electrically isolated. Just using isopropanol to remove this stuff. The old grease. Same for this. Just some alcohol on there. Just cleaning it a bit. You also want to clean the transistor from the backside, of course, and the little sheet that was in there. So this insulator sheet here. So yeah, some new thermal grease on there and then back together it goes. I'm just using this vermelite paste, which is a silicon-based thing. So a bit on the chip here, a bit on our transistor. And also on here. Oh, and of course we want to clean the part where it goes into the case here as well. So this goes on here like so. The transistor needs its little blanket to insulate it. And its little washer from the other side. We want to turn these counterclockwise until they click into the threads and then screw them down. This thermal compound is non-conductive, so we don't risk anything. It's literally just conducting heat away from the components, which is the desired effect, obviously. You only need a very thin layer of this stuff. Now we want to clean the potentiometers and the switch here a bit with some contact cleaner. And these do work, so I'm not going to bother too much with these. Just going to spray some in there. I think from this direction, that's where the cutout is. And then just work them a couple of times and spray them again. And I'm going to do the same for the switch, which is the 3345 switch. And this is just a standard switch, so we can just get in there quite nicely from here. I think we've done about everything we can for this circuit board. Should put it back in after cleaning the backside. Okay, some heatsink plaster on this part here. On here, I think. That's where the heatsink connects to the case. And then this all should just screw in again after routing the cables so that nothing catches anywhere and you don't screw anything through the cables. And again, you want to turn these counterclockwise for a bit until they clip in and then screw them down, because some of these screw into plastic or into aluminum, which this whole top part is made of. Want to make sure that the screw here is the ground screw with the little washer. The important thing is that you get the ground screw in the correct position. Maybe we could also add a bit of contact cleaner to that, because that's supposed to make contact. That's not really necessary, because these star washers usually grip into the metal there quite well. Okay, that's our circuit board back in place. Now we can work on the mechanism, I guess. There's actually a little extra washer on this side here too for the transistor that I forgot the first time around, and then I forgot to film the part where I put that back. There's a little spring-loaded washer and a regular washer. Over the plastic washer, the insulator that's in here. So that's pretty much 3 steps and then the nut from this side for the transistor on the heatsink. This is the stop mechanism here, and we can add a bit of lubrication to that as well. I think I'm just going to clean it with a Q-tip. There's some gunk in there. So yeah, down here there's a bit of brown gunk. Yeah, that looks good. Just going to put a bit in there, I think, silicone grease. And of course, this plastic stuff is going to get brittle eventually and crumble, basically. But it still works thus far. So I hope I'm not going to have to do any repairs on that. Okay, I guess that concludes this portion. And now we're going for the mechanical part of this service, maintenance, restoration, future-proofing, whatever you want to call it. So we need the base of the turntable. In order to get to our dampening oil, we have to get this whole tone arm assembly out of this. And that's going to be a bit precarious, so we're going to have to take extra care. We're going to have to be very careful about this. This cable is the one that provides our sound output from the cartridge through the tone arm. And we are going to remove that. This is just a cable tie. This is just a bent wire, basically, that holds this in place. And then we're going to have to remove this screw, and there's another screw over here that's under a little rubber cap. And we can take this whole thing out, I guess. So there's our little rubber cap. We're going to take that out carefully. Yeah, that just comes out. And there's our screw. There's little washers under these as well. Very nice. So the whole base needs to come out because we can't get to our dampening fluid from the top side here, which is in this cylinder here, as we're going to see. Now this should all be loose. Yep, it is. And there's some parts we want to lubricate. We're going to work on that in a second. This is what this looks like. So we want to be super careful with this, obviously. Just going to try to prop it up in some proper way. Should have thought about that earlier, I guess. Don't want to put too much weight on the tone arm. Just using some rolls of tape here. And this whole other part we're going to put away for now. So this is basically where all the magic happens, at least in this turntable. This is the cylinder with a shaft that goes to the plastic part we've seen from the top, that actually where the arm sits on, and then that delays the time that the arm needs to set down on the record. And as you can maybe see, there's quite some liquid leaking out here. So you want to be very careful with these here, because these are the very thin wires coming from the cartridge, from the tone arm connector here. And yeah, you don't want to mess with that. Can add some lubrication here later. That's going to make things a bit nicer. But we want to get to this. So we want to get into this cylinder here. We want to take the shaft out of that. And this is attached to this metal plate that you can see underneath. So we have to remove the anti-skate arm here, this little thing with the spring on it. And we also have to get this out of the way. And then there's one screw here and one screw under here that we have to remove to get the whole construction out. I'm going to start with removing the anti-skate thing, which is a bit fiddly and delicate, but we should be able to get that out quite easily. It's also lubricated, so this should go somewhere like here. And the whole construction with the arm should move out of the way so we can get to that screw there. Super afraid we're going to break this, but yeah. So we need to remove this screw here and this screw here. And then this metal plate, yeah, is free. We have to remove the lock ring from our cylinder here, and then we can pull the whole thing up, I think. This is an E-ring, I think. There we go. That's our lock ring. It's totally coated in our old dampening fluid, which leaked out very slowly because it is of a very low viscosity. So yeah, this is the mechanism. You don't want to have the spring flying anywhere. This is going to get quite messy. And now you can pull this whole thing out, I think. Yeah, there we go. That's our shaft. We want to clean the old lubricant out of this. And of course, we want to clean the shaft. So this shaft has 3 little notches that you can see there, 2 little rings that the lubricant or the dampening fluid naturally sits in. So we're going to have to clean this thing thoroughly, and also the shaft portion of it, and put new dampening fluid in there. And that's going to last a while, hopefully. Just using isopropyl alcohol here on this part. And also on the little washer parts, the lubricant has leaked onto quite significantly. So now we're going to put the new dampening fluid into these ridges that are on this. And these are available in different viscosities. I chose 500,000 CST. These are also available in 300,000, 400,000, 600,000. And you need different viscosities for different turntables, basically. You can, of course, also use this to change the behavior of your turntable if you like. So the higher numbers are slower. So this stuff is 500,000. And we want that in our ridges. And then we can set this back down, I guess. So and then our screws can go back in, I think, at first. ring, washer, and the lock ring. There we go. So that should be our Q-arm lift lubricated. I don't even know if you can call that lubrication. It's dampened. It's probably the right way to put it. So I'm just double checking if this works actually. So this is now in the up position. Lowering it down. And it's very slow. Just how I like it. So that was successful, I guess. Let's reassemble the rest. So I also want to put some lubricant on this thing here and remove the old lubricant. I'm not going to use the dampening fluid for that, but some regular silicone grease, this stuff here, on the part that actually moves, which is here. Okay, and now this thing goes on there. The washer gets some extra grease as well after cleaning. And then we have our screw to put in. Yeah, that works beautifully. I'm also going to clean these parts here and put some lubrication in there. But that should be relatively trivial. The worst part is getting this whole bezel here out and putting new dampening fluid in. You have to be patient and careful, as with all things, but yeah, it wasn't that bad really. So I guess that is our tone arm refurbished. Pretty satisfied with this. All we have to do left, I guess, is to clean the bottom part and put the tone arm assembly back in. So this whole part just needs a good cleaning with, at first, we're going to clean the dust out of this, which of course gathers there over the years because this is the lowest part. I'm going to use a vacuum cleaner with a little brush attachment and just clean this out. And then we're going to re-lubricate this mechanism here, spray some contact cleaner in this switch, which is actually the on-off switch that switches the motor and the whole electronics on and off. That got rid of most of the dust. We're going to spray some contact cleaner in here, lubricate all the moving parts. There's quite a few here. This slides in here. And we are going to take care of the parts on the back side of this later on when we have more of this assembled again, because it's easier to get there. You can see these little plastic things here. This is actually all spring loaded. So the whole chassis is only connected with springs to minimize vibration. That's pretty clever design actually. So this is all suspended. The whole top part with the controls and stuff is all mechanically separated from the parts that actually are vibration sensitive, like this part here, where the motor is and the platter is going to sit on, and the cartridge, of course, with the needle. So I'm just going to do the same that I did for the other parts. I'm cleaning the old lubricant and putting new lubricant in, and that goes for all the little moving parts here. Don't really have to disassemble this any more than I just did to do this. I'm just using a regular silicone grease for that, of course. And we're also going to put 3 little drops of sewing machine oil in here. That's where the actual movement happens. This was a bit wonky. Now it feels smooth again. So you want to oil that part here. There's a little slot that you can see there, and remove the excess oil there. do with a Q-tip. We're going to clean and re-lubricate the mechanics that are on the flip side of this later, once we have this reassembled a bit more. Don't forget the little washers. I'm going to spray some contact cleaner into all the connectors. Need a new cable tie here for this cable. I think I thought of pretty much everything at this point. We're going to see. I'm going to wipe this part down a bit with alcohol as well. Especially because we have lubricant everywhere else. So, and then that goes back into our plater here. Just removing some of my fingerprints. Then these knobs have to go back on, of course, which I'm also going to clean. I think at this point we can already close the whole thing up again and put the feet back on. And now we can work on the mechanics. We can take this whole bottom plate out with the screws around the parameter and then see the mechanical parts, the gears and such, which I don't think require much lubrication at this point because I lubricated them like 10 years ago and that stuff lasts a long time basically. And I just realized I think we have to remove the feet, these ones here, to get to that. Yeah, so we're just going to take these off again. Sorry. Now we should be able to lift this whole plate. Yep. And there's the mechanical parts there. And this is all a rubber sheet here. Yeah, there we go. That's all nicely lubricated still with my lubrication that I did like a couple of years ago only. That's all good. Yeah, we don't have to do anything. If you never open this, you have to lubricate the moving parts here as well. So now the platter can go back on. Now we go. And our counterweight can go back on. And I'm going to clean the lid a bit more as well, of course. This is a bit scratched, but not too badly. So it doesn't worry me too much for a turntable. This vintage, you can literally just pull it out here. So this gets a good scrubbing with some window cleaner. I'm going to clean the rubber part in the sink, I guess, with some dish soap. And then it's time to test this thing. Whew. Okay, got everything cleaned rather nicely. Let's do a bit of a smoke test, I guess. I'm just going to plug this in now and see if it explodes. Didn't explode. And it spun a bit, because it was probably still in its stop mode and should start spinning. Didn't explode yet, that's a good sign. That is a very good sign. And I'm just quickly going to set this cartridge up. There's a lot of videos about this process on YouTube, so I'm not going to show you how to set up a record player cartridge. I set up the tracking force and the anti-skating preliminarily. I'm going to do a proper setup on this eventually. Just wanted to check if this still spins, which it does. And we're going to have to set this up properly to its speed. But all we wanted to know is whether our lift is back in business, and it actually is, which is really cool. So it is slow lift again. There you go. That was what I was after. And yeah, stop mechanism probably still works. It does. Nice. This is a lot quieter than before I lubricated this, which is to be expected. So all the mechanisms are a lot quieter because they are properly lubricated again. It spins nicely and evenly as far as I can see. I'm going to turn off the lights to see if the speed is actually correct. In case you're wondering which record I put on there, we're not listening to this because of copyright reasons, but this is Pretty Girls Make Graves, The New Romance, which has just been re-released, originally from 2003. One of my favorite records at the time, and I never had it on vinyl, so now I have in the nice white vinyl edition. It shows this because it's easier to see on camera, actually, than a black record. So I'm just going to let this spin in the background here, and I'm going to report back if anything got overly hot or exploded or anything like that. I don't think so. It's going to work fine. Yeah, after about an hour or so of spinning this, I'm pretty confident that my little refurbishment worked, and hopefully I'm going to get another couple of decades out of this record player because I really, really love this thing. If you ever come across one of these, don't pass on it. It's really, really a good turntable, and with the proper cartridge you can put even better cartridges in this, of course, but this is kind of a good match for this kind of turntable. Sounds way better than the original cartridge these came with. Hope this was informative and maybe a bit entertaining even. Thank you so much for your time. Special thanks, of course, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. Very, very much appreciated. You make these videos possible, and you also make it possible for me to get some interesting devices from time to time. So thank you very much for your support. Yeah, that's it for today. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye!